Okay, I just got done showing you how easy it is to set the tool heights on a bed mill. Now what about an e-mill? The big difference when it comes to setting the tool heights on an e-mill is the fact that the distance from the top of the table to Z-home on an e-mill is going to change. Now on a bed mill, the distance from the top of the table to Z-home is always the same. It's an absolute. So we use that known distance to come up with a tool height offset value, or the difference in length for each tool, using that known distance. Well, in an e-mill we can't do that because one day the knee could be here and the next day it could be a foot lower. So the method that we're going to use on an e-mill is we're going to come up with a standard in which to measure the tools from. This standard is called a reference tool. Now in this case, my reference tool is not an actual tool. What I've done is I've taken a piece of 1/2-inch drill rod and permanently locked it in a dedicated tool holder. Now what we're going to use this for is we are going to measure the difference in height between the reference tool and all my other tools. Now I could actually physically measure this with a pair of calipers and type the number in the control. The control needs to know for the height offset value for my tools, what it needs to know is the difference in length between my reference tool and my actual tools. Now rather than physically measuring it, in this case it looks like about 4 inches, I want to do it as accurate as possible. So I'm going to use the actual CNC machine to tell me the difference in length between my reference tool and my actual tools. Let me go show you how that's done. Okay, let's start with the reference tool. How do I know how long to make my reference tool? Well, a good rule of thumb is take the amount of z-axis travel you have. In this particular machine, it's about 4 1/4 inches, and add it to the shortest tool that you're going to use. So my reference tool is approximately 4 1/4 inches longer than the shortest tool that I'm most likely ever going to use. That's just a good rule of thumb to get you in the ballpark. Okay, I got my reference tool loaded up in the spindle. Let me explain to you how we're going to use the reference tool to measure the difference in length between all the other tools. What we're going to do is jog it down to a position and have the control remember where that reference tool is. Then we'll load up another tool, jog down and touch that same position. Now it's going to take an additional amount of movement for the control to get that shorter tool to that same position. The control then knows the extra distance that that tool had to move to touch the same spot that we used to touch with the reference tool. That is the height offset value. That is simply the difference in distance in length between the reference tool and my tools. Now, for a reference position, there's some better places than others to use for that actual position. What I don't want you to do is use the top of your stock or the top of your workpiece. The reason for that is that may be gone in an hour or the next day. So then I would have to reset that position again since I don't have this position anymore since the stock is removed out of the vise. So you want to pick a place that you can always get to, like the top of the table, or in this case, the top of the vise. I add an extra little thing here too, is I use a 1, 2, 3 block off the top of the vise. What this does for me is when I'm jogging down, it makes it easy for me to move the 1, 2, 3 block out of the way, so it makes me easy for me to touch off both the tools and the reference tool to the reference position. So in this case, the top of my 1, 2, 3 block is my reference position while it's sitting on the top of this vise. First thing I'm going to do is crank the knee up so that it's close to the reference tool. The reason why I'm doing this is that I don't want to use up a lot of my Z travel jogging the reference tool down to the top of the 1, 2, 3 block. So what I'm going to do is I'm going to just eyeball it here and get it within 50 thou or so. I'm going to lock my knee down. The next step is for me to hit the F1 Z ref button and some instructions show up on the screen. They say load the reference tool. Well, I've already done that. Then they say jog to the reference position. Now I'm about 20 or 30 thousandths above my 1, 2, 3 block. So what I'm going to do is I'm going to go into incremental mode and jog down in slow incremental at times 10. Each time moving the 1, 2, 3 block out of the way. Now the goal here is for me to just touch off the reference tool until it just grabs the 1, 2, 3 block. I just got to that point. Now I'm backing up a little bit because I was jogging down 10 thousandths at a time, and I switched over to 1 10,000ths and I'm backing up so that that just kisses the 1, 2, 3 block. Now, I have the reference tool just touching the 1, 2, 3 block. This is the reference position. I'm going to tell the control right now to remember that position. So it says the third step, press F10 to save the reference. Now all the control has done is simply memorized where it's at. Okay? This is a temporary position. Now we're going to take the rest of our tools that we have for this job and we're going to load them, come down and touch off the same position, and the control then is going to measure the difference in distance that it had to move down for that particular tool to touch the same position, effectively giving us the difference in length between this reference tool and all our other tools. Let's go ahead and do that. I'm going to hit Tool Check, bring the reference tool back to the tool change position. Okay, I got my tool number 1 loaded up. Jog it back over the top of the vise. Now, just as a reminder, during this whole process, you don't want to move the knee. When we're done, we can move the knee wherever we want. So if we had to get a big part in there, the machine with these same 3 tools, we could do that. No sweat. But while I'm measuring the tools, the knee's got to stay at the same position. I'm going to take my 1, 2, 3 block, put it in position, and I'm going to jog down. I'm in fast jog right now. I'm going to switch over to slow jog when I get close to the 1, 2, 3 block. Okay, I'm within 20 thousandths or so, so I'm going to switch over to incremental. Okay, I'm switching over to tenths. Back up a little. There we go. The tool number 1 is just touching the 1, 2, 3 block. Okay, I got tool number 1 just touching the 1, 2, 3 block. What I want to do is make sure that the cursor is on the height offset value for the tool that I'm measuring. This is number 1. So move the cursor to height offset value number 1 and hit F2, which says manual. That's so it's manually measuring the difference in length between our reference tool and that tool number 1. The value that it just came up with is minus 4.1140. That means that tool is minus 4.1140 inches shorter than our reference tool. That's all there is to it. Now I'm going to hit Tool Check, jog on over, get my tool out of the way, and switch over to tool number 2. Okay, I got tool number 2 loaded. I'm going to jog back over the vise, grab my 1, 2, 3 block. I'm going to fast jog down, get in the ballpark. Looks good. Switch over to incremental. There we go. Okay, I just got tool 2 touching the top of the 1, 2, 3 block. The controls automatically move the cursor down to the next tool height offset value for me. So all I have to do is hit F2, manually measure. Now as you can see, this tool is a little longer than tool number 1. So its height offset value is 2.9238. That means that tool is 2.9238 inches shorter than our reference tool. Okay, we just go grab tool 3 now and do the same thing. Okay, I got tool 3 loaded, which is a drill chuck. Has a 200 thousandths drill in it. I'm going to jog it back over the vise. Got my 1, 2, 3 block. Get a fast jog down, get in the ballpark. Switch over to incremental times 100. Get her down real fast. Okay, within 10 thousandths or so, switching over to times 10. Gonna get it so that drill just kisses that 1, 2, 3 block. Okay, we got the drill just kissing the 1, 2, 3 block. This is tool number 3. Gonna make sure the cursor is on height offset value 3. Hit F2 to measure it. Now, the value it put in for the drill is only minus 0.4249. That means that drill is only a little bit shorter than our reference tool. Okay, that's all there is to it. I've measured the height offset values for my 3 tools to do this job. Now, if I had 25 more tools, I would just continue on in the same method, touching off the top of the reference position here, measuring the height offset value for each individual tool, and be sure to hit F10 to save the work that you've done. Now I've got these 3 tools in there set. I'm ready to go program and set my part zeros and cut my job. Now some folks that are watching this training video that have some prior CNC experience might think that using a reference tool is like adding an extra step to setting your tool height offset values. When in reality it's really a time saver. Because the old method of setting all your tool heights off the top of the work may work, but what it does is it requires you then to reset or remeasure those tools for every single job that you do, even if they're the same tools that you just got done using. So if you're a job shop and you're making 2 or 3 or 5 different parts a day, let's say with 5 tools each, you have to reset those tools each time. So you're setting 25 times in a day you're setting tools. With the Centroid reference tool method, it reduces setup time, because if I have those 5 tools, I only have to measure them once against the reference tool. I can then machine as many different parts as I want. What's great then, for setting your part zeros for all those different parts, I pick any one tool that's set up in the tool library. It doesn't matter which one. Any tool set up in the tool library to set my work coordinate, my part zero, and then all the other tools in the tool library are automatically set to that 0. I don't have to individually touch each tool off the top of the work. As soon as I measure them against the reference tool, pick any one, set that one, use that one to set the top of your work, and all the other ones are automatically set. Load a different job, pick any one tool, use that tool to set the top of the work, all the other tools are automatically set. So every time I do a different part, it's saving me all that immense amount of setup time that I would have to do with the old method of setting off the top of the work zero each time. Another advantage is, out of these 5 tools that I set, if I break one of them, with the old method, if you break any one tool, you have to reset all your other tools because they're relative to each other. With our method, they're all measured off the reference tool. So if I break one tool out of 25 that I'm using, all I have to do is measure just that one tool again, or remeasure just that one tool when I replace it against the reference tool. All the other tools are still the same, still measured off the reference tool. I don't have to remeasure them. So you got a big time saving advantage to going with the reference tool method. After setting my height offset values with my reference tool, I'm free to move the knee to whatever position I need. Now, one of the reasons why I'm stressing this point is that I don't want you to confuse setting part Z0 positions with setting your tool height offsets. It kind of looks the same. You're touching the tool off the top of a position. Okay? I don't want you to confuse the two because they're completely different. When we were using the reference position and touching the tools off, all we were doing is telling the control the difference in length between all our tools. Now, when I use that same tool to come back and touch off the top of my work to set a Z0 position, what's great about the reference tool method is all those other tools are automatically set to that position as well. So I only have to touch off the top of my workpiece once with one tool. And it can be any tool that's set up in the tool library. Now that you know how to set tool height offset values manually using a 1, 2, 3 block and a reference tool, let me show you a faster, easier, and much more accurate way with the Centroid optional TT1 TouchOff Block. The TT1 plugs into the back of the control, and the control will automatically jog the tool down, touch off the block, and record the tool height offset value in the library for you automatically. Let's go check out how it works. I'm going to plug the TT1 in, and again we want to use the top of the vise. There's a nice magnet on the bottom of the TT1, and I'm going to use the top of the vise or the top of the table. Either one works great for a reference position. Now we're going to set a reference position just like we did with the 1, 2, 3 block. So we're going to load the reference tool. Except in this case, the control is going to automatically move the reference tool down to the TT1 and touch off of it. So I'm going to jog on over. And again, I want to reduce the distance between the reference tool and the TT1, just like I did on the 1, 2, 3 block, so that it's only like 10, 20 thousandths or so, but not touching. When using the TT1, you still have to set a reference position. So using the same menu, the same tool height offset menu that I was in before, I'm actually going to hit the exact same F1 ZREF button as I did before with the 1, 2, 3 block. Step 2 says jog to the reference position. That's what we did with the 1, 2, 3 block. But now I'm using the TT1, so it says or press F3 to seek the probe. I'm going to hit F3, then cycle start. The control moves down, the reference tool touches off the TT1 and sets a reference position faster than I can say it. Man, that's great. Now I'm ready to go measure the other tools. Insert tool 1. Just like I did before, I'm going to jog back over. Going to make sure my cursor is sitting at tool height offset number 1. Now I can do two things at this point. I can hit F3 auto. As soon as I hit F3 auto, the tool is going to automatically come down and touch off the probe. But in this case, the tool is very, very short, and I'm really not quite sure whether it's lined up with the probe. So that's easy. I can just jog down to get close to the probe to make sure that things are lining up. Now things are looking like they're lining up real good. Now I can hit F3 auto, then cycle start. The tool automatically comes down, touches off the probe. If you're watching real close, you'll notice that it hits the probe once at a fast jog rate, backs up a little bit, and then slowly comes in and touches it. That's to achieve maximum accuracy. The TT1 is as good as your machine. If your machine's holding tense, you'll be able to repeat tense on measuring tools. Now let's load the next tool. Okay, I got tool 2 loaded. I'm going to make sure the cursor's sitting on tool 2. I'm going to hit F3 auto and then cycle start. Tool 2 is going to jog on down to the TT1, touch off. Bingo, that's all there was to it. The control just recorded the height offset value for tool 2. Now I do the same thing for tool 3. Make sure my cursor is at the tool number that I'm recording. Away we go. There we go. I just got done measuring 3 tools in about a quarter of the time that it took me to do it with the 1, 2, 3 block. Much more faster and accurate, pays for itself in a short period of time, especially if you're constantly breaking down and setting up different jobs and having to measure different tools all the time. If I can remove one drill bit out of a drill chuck and put another bit back in at approximately the same height, then that drill bit has the same tool height offset as the one as I took out. You could actually have a group of drills. Each drill would be tool 3, 4, 5, 6, but they're all going to have the exact same height offset value. And when the control comes up and asks you for a tool change, you're not actually taking the drill chuck out, you're just sliding the new drill bit in at approximately the same length as the one you took out. Hitting cycle start and away you go. And there's a couple different ways to do this. If you're drilling through holes and it's not that critical, you can just use some magic marker, make a mark on there, line the mark up. Yeah, it's within 10 or 20 thousandths, but that's going to be good enough for a through hole. Another method might be putting a collar on the drill bit so that you can repeat more accurately to the same position. That's a quick trick. You might have 2 or 3 drill chucks that do 2 or 3 groups of ranges of different size drill bits. Obviously, I couldn't take a 3/4 inch diameter drill bit and line it up with this 1/8 inch. It's only going to work over a range of drill bits. So that'll save you from having to buy a ton of different drill chucks. Another little trick I'd like to tell you is if your program is only using one tool, it is not necessary to measure it against the reference tool. The reference tool is only really necessary when your programs have 2 or more tools in them, so the control knows the difference in height between the tools. Well, if your program only has one tool, there's nothing else to worry about. This tool, however, will still have a tool number. Just make sure that the height offset value for that particular tool number is 0, and then when you're setting your part 0 position, be sure to tell the control that's the particular tool that you're using to set your part 0, and that tool is the tool number in your program. When those things are met, you do not have to measure that tool off the reference tool.